Alright, so we've got a gas stoichiometry problem here. What volume of oxygen gas could be generated at STP by the decomposition of 195 grams of FeClO32? So we're starting out with the grams of FeClO32, and eventually what we're going to do is we're going to use PV equals nRT in order to get our volume of oxygen gas. But in order to do that, we're going to need a number of moles of oxygen gas. So in order to do that, we're going to do a little bit of gas stoichiometry. Now, the little flowchart I like to use is QA goes to mole A, goes to mole B, and then that goes to QB. Now, for QA here I'm talking about is going to be the 195 grams of FeClO32. So that's what I'm going to start out with. 193 grams FeClO32. So do times and a line. Now we know that grams of FeClO32 goes on the bottom because that has to cancel with this one. And what we want though is moles of FeClO32. That's to begin with. And the relationship here will be 1 mole is equal to the molecular weight in grams of FeClO32. And next we need the moles of CO2. So the moles of FeClO32 will go on the bottom, and moles of O2 will go on top. Now the relationship between these we get from the reaction, and we see that 1 mole of this will produce 3 moles of O2. Alright, so that's going to give us a certain number of moles of O2. Next we can use our PV equals nRT, and if we're going to do that we know that we're going to have to write our values down. So P equals NV equals N equals R equals and T equals. Always start out with the value of R, 0.08206 liters, atmospheres per mole per Kelvin. Also written as liters, atmospheres, moles, and kelvins. Alright, so that's a given quantity, and we got per mole per Kelvin. Those are for -1, so those end up going on the bottom. Alright, so pressure. Now look what it says here. It says what volume of gas could be generated at STP. Now STP is standard temperature and pressure, and it's always going to be 1 atmosphere and 273 Kelvin. So the pressure here is 1 atmosphere, not subject to significant figures, that's going to be an exact number. The volume, that's what we're looking for. N, that's what we figure up from over there. So that'll be a certain number of moles. Temperature, that's going to be 273 K. Alright, so now we can do our thing. We've got PV equals nRT, so we know that V is equal to nRT over P. Okay, so the N is what we get over here, and that'll be a certain number of moles, times 0.08206 liters, atmospheres, moles, and kelvins. Temperature, 273 K, and pressure, 1 atmosphere. Alright, so since this isn't subject to significant figures, we're going to end up with something that has 3 significant figures in the answer, and that will be in the unit of liters. Now what you're going to see is that the kelvins will cancel, the atmospheres will cancel, and the moles will cancel, and we'll be left with liters as our unit.